Hi children, today we are going to start the third video of the topic integration. Today we are going to concentrate about finite integration. What is finite integration? If we simply say a finite integration is an integration with boundaries. In former topic, in the integration what we work out, we didn't see any kind of boundaries at the top and bottom. In our former topic, when we work out with infinite integration, there we obtain an expression. But here with the boundaries, if you work out this integration, that means finite integration, you will receive an answer. Later on this video, we will discuss about how to obtain an answer from finite integration. In a finite integration, as I mentioned you in the previous slide, you get two boundaries. The top one we call as the upper boundary and the bottom one we call as the lower boundary. Usually, we apply a higher value for the upper boundary and a lower value for the lower boundary, but that is not a must. Certain cases are there, it interchange, but in general the higher value goes to the upper boundary and lower value goes to the lower boundary. The other difference over here is when you are working out with this, in our previous topic infinite differentiation we add the plus c to the end, that is called a constant where we have to find. But in this finite integration we are not applying any kind of constants because that constant get cancelled out when you are working out the last extent. Therefore it's no need of applying a constant to the expression. Then our objective is how to perform with this finite integration. Step 1, we have to do the usual integration where we used to do in the previous topic. Then after that, substitute the upper boundary value into the expression what you obtain at the integration. Then in the next step, you have to substitute the lower boundary to the same expression what you obtain from the integration. At the final stage, you have to subtract the value obtained by the lower boundary by the value obtained by the upper boundary. Therefore, you have to subtract the step number 3 out of step number 2 to obtain the final answer. We will try to understand this much clearly from next example. In this example, our problem is to integrate 3x squared from plus 5 to plus 2. That means here the integration function is 3x squared, our upper boundary is 5 and the lower boundary is 2. How to perform with this integration? First you have to do the usual integration. If you integrate 3x squared, you will obtain the answer x cubed. Then after that you have to substitute the upper boundary 5 instead of x in the answer x cube. That is 5 cube, answer is 125. Then after that substitute the lower boundary 2 into the expression x cube. There you get 2 cube, answer is 8. Then you have to subtract 8 out of 125 and you obtain the final answer as 117. That is the final answer for the integration 3x squared from 5 to 2. Hope you have understood. Now let's to verify from our next example. Our problem is to integrate 2 to minus 1 3x squared plus 4x minus 2 dx. Therefore, in the step 1 we have to do the usual integration. If you integrate 3x squared, your answer is x cubed, plus 4x integration is 2x squared, minus 2 integration is minus 2x. Then after that you have to substitute the upper boundary, minus you have to substitute the lower boundary. I have done step number 2, 3, 4 at once. If you substitute the upper boundary 2 into the expression x cubed plus 2x squared minus 2x, you receive the answer 2 to the power 3 plus 2 times of 2 to the power 2 minus 2 into 2. That is a substitution of 2 into the expression x cubed plus 2x squared minus 2x. Minus, then you have to substitute the lower boundary. Lower boundary is minus 1. If you substitute into x cubed plus 2x squared minus 2x, you will receive minus 1 to the power 3 plus 2 times of minus 1 to the power 2 minus 2 times of minus 1. Then if you simplify this, you receive the answer 9. Our next question is to integrate from 2 to minus 1 x plus 2 times of x plus 1 dx. Here we cannot integrate this question at once. First, what we need to do is we have to expand the bracket. If you expand x plus 2 times of x plus 1, you receive the answer x squared plus 3x plus 2. Then after that, you can replace x squared plus 3x plus 2 instead of x plus 2 times of x plus 1. Then if you use the usual integration theorems, you will receive the answer x cubed over 3 plus 3x squared over 2 plus 2x. Then we have to follow up the next steps. Substitute the upper boundary 2 minus substitute the lower boundary minus 1. If you substitute 2, you receive the answer 2 cubed over 3 plus 3 into 2 squared plus 2 plus 2 into 2 minus 1 cube over 3 plus 3 times of minus 1 squared over 2 plus 2 into minus 1. If you simplify this, you receive the answer 81 over 6. That means if you integrate x plus 2 times of x plus 1 from 2 to minus 1, you receive the answer as 81 over 6. What are the applications of this finite integration? One application is to find the area between a curve and the x-axis. As shown in the diagram, if you want to find the area A, what you need to do is you have to integrate the curve from given boundaries A to B. That receives you the answer of the given area A. In this problem, they expect us to find the shaded region enclosed by the curve and the x-axis from 2 to 4. Therefore, to obtain this area, what we are supposed to do is you have to integrate the curve minus x squared plus 6x minus 5 from 2 to 4. Then, if you work out this integration, you receive the answer. Means if you integrate this, you will get the answer minus x cubed over 3 plus 6x squared over 2 minus 5x. Then you have to substitute the upper boundary 4 minus substitute the lower boundary 2. There you get the final answer 22 over 3. Therefore, the value of the shaded region is 22 over 3. In this example, we need to find the area enclosed by the x-axis and the curve y equals to minus x squared plus x plus 12, and the boundaries are minus 3 to 4. Therefore, you have to integrate the curve from 4 to minus 3. Always when you write these boundaries, make sure to write the higher value at upper boundary and lower value at the lower boundary. Therefore, if you integrate minus x squared plus x plus 12, you receive the answer minus x cubed over 3 plus x squared over 2 plus 12x. Then after that, you have to substitute the upper boundary 4 minus, then substitute the lower boundary minus 3. If you work out, you will receive the answer 343 over 6. Okay. In this question, they expect us to find the area enclosed by the curve and the x-axis. The curve is y equals to x squared minus x minus 12, and the boundaries for this question would be minus 3 to plus 4. To obtain this area, you have to integrate the curve x squared plus minus x minus 12 from 4 to minus 3. If you integrate x squared minus x minus 12, you will obtain the answers x cubed over 3 minus x squared over 2 minus 12x. If you substitute the 4, you will receive the answer 104 over 3 plus, then if you substitute minus 3 into the answer, it's turn up into minus 45 over 2. If you work out with this answer, you can see a very special feature. Your answer is a negative value. We know that area cannot be a negative answer. Then how does this value become negative? The reason is, you can see from the diagram, the enclosed area is below x-axis. Always when you are working out with this integration, you receive a negative answer for the areas below the x-axis. So here after, when you are working out with such areas, you have to make sure You have to write only the modulus of the figure. That means the area is 343/6. Hope you have understood this topic and enjoy my video. Thank you.